Hello, my name is Banerjee. I'm head of a UK smart card consultancy called GlobeSmart, and we advise on smart card usage to corporations and governments on a worldwide basis. I've been involved in the smart card industry now since the late 80s, so really over 20 years, and started a number of smart card companies during that time, some of which are doing extremely well in the transportation, loyalty and handheld devices sector. I was head of Java cards for 4 years between 2004 and 2008, so understand the Java card and the SIM card industry very well. And I have a particular personal interest in e-money systems, especially when deployed to the unbanked and to the poor communities of the world. Rather than a recommendation, let me give you my perspective. You see, the way it goes is that there is no real alternative to adopting Java card technology, because there is a gradual move, as always with all operators, towards having a subscriber base that's moving from single application to multi-application. You're always going to greater orders of complexity, where people with handsets will want those handsets to do more and more. And there's always a need from an operator perspective to follow the lowest cost path. Business always follows the lowest cost path. It may sound strange to think that Java cards may be the least expensive route, but it's rather like building a house. The price of a house is much cheaper if you build it without a foundation. But you can't get a good house without a good foundation. You never see the foundation, but you derive benefit from it at all times. And Java card technology is a bit like that. I'm sure other operators here and other people speaking have talked about how migrating to Java cards leads to much greater interoperability between applications, between different card suppliers, SIM suppliers, and a shorter time to market because you have a known environment that's highly under control. And because of this shorter development time, you get much lower costs. But one of the things about Java cards is that it provides you with a stable framework. If you imagine that your SIM cards may have a lifetime of anywhere between 9 months and several years, during that time, the silicon on which SIM cards are being produced will have adapted every 18 months to 2 years. And so in the lifetime of some of your card populations, you would have had to change SIM card platforms. And as these changed and the same applications are running on them, the testing environment needed to keep all of these operating correctly is absolutely enormous. If you were to have a stable base of a platform that migrates from one piece of silicon to another, provides you with the same environment, irrespective of where that silicon comes from or where that SIM comes from, is a much easier path. The traditional view that I've come across in China and in other large populous countries is that it's better to have a local version of things. Why should we have a foreign standard when we have such a high number of people, our language and culture are so different, that it's worthwhile taking a specification from the outside world and modifying it for the local environment. And this has been done very successfully in a number of areas. And in China, the Chinese have tended to say, if you want to do business with us, this is the specification we recommend, and therefore please adopt it. But GSM is different. GSM is global. And as we've just seen, China has now become the world's #1 exporter, overtaking Germany to do so. It needs to export to thrive. And in order to export and into those international markets, it needs international standards. In order to adapt to these international standards, the Chinese operators don't need to set up their own SIM alliance or ETSI. They need to join SIM alliance and ETSI. They need to influence the world by participating within these organizations and then putting their own view and making modifications and changes and exerting control from the inside. Yes, it has taken a number of years for the European operators to adopt Java Card. And I suppose really from the early 2000s onwards, we've seen an ever-increasing number. And certainly within my time, 4 years at Sun Microsystems, we saw Java Card usage triple, if not quadruple, within 4 years. But it has been a learning curve. ETSI has learned a great deal with the GSM standards, taking feedback from the operators. And the operators themselves have seen this new technology, new SIM suppliers have been trying to put it together in a market that really has been explosive. And all along, Sun, with their Java Card standard, has kept up with what operators need, what ETSI demands, and make sure that the specification can supply the components that are required. But this learning curve is coming towards its end. And the Chinese operators can really take advantage of the past learning that has come from this curve. There'll be no false starts because all the false starts are known. They're documented. What the operators can get is 20/20 hindsight on what will work and what will work well. They'll be able to apply that with much newer technology, which was not available a few years ago, to get even better solutions. And as Chinese operators grow and become wealthy, they will acquire foreign operators. And there'll be a need to integrate the SIM platform across their section of the community and the operators that they acquire. Java Card technology will simply allow that integration to be much, much easier. I think there's a huge amount of hype over NFC and certainly some confusion as well. Let me just put the perspective on NFC. As far as I can see, it's a contactless interface. And this contactless interface effectively allows the SIM card within a phone to have multiple applications. Because now for the first time, you can use an application on the phone that is not the SIM application, not the mobile phone application, but another application which can connect to things, devices in the outside world using this contactless interface. You don't need to extract the SIM card out the phone, and as a result, the SIM operation, the mobile operation, continues in parallel with the other contactless operation that you're doing. One of the beauties of NFC is that there's no pairing as in Bluetooth. So you can literally go up to another device, another NFC device, and be able to talk to it. Therefore, it's an interface, it's not an application. So it's a question of what can we do with this new interface? Well, if you're going to run multi-applications within the SIM over the NFC interface, then these applications really split down into two broad categories: secure and insecure. The insecure applications have largely been done because they run within the phone handset itself, and you only have to look at iPhone and the library that comes with iTunes to know that a huge number of applications have been written to run within phones, and this could be migrated to any phone, including an NFC phone. Simple applications such as reading NFC tags have also been done, and this is promoted by the NFC Forum and other people. However, the next generation of applications for NFC phones will require security because they'll require things like identification and payment and so forth. And that security requires a tamper-resistant module to execute secure applications within them. The SIM is one of the standard tamper-resistant modules we have. Now, as it happens, the SIM belongs to the operator. So it's really the operator's connection with his subscriber community. If we need a secure module to run the application, and the application is multi-application, then the Java card becomes one of the best environments for that. Because there is no other environment which is secure, can run multi-application environment, and is available on an open nature from so many sources. It's very difficult to find the killer application on NFC. There's been a huge number of pilots, but very little in the way of rollout. In my opinion, that is principally because we do not yet have interoperability in areas such as identity, payment, or counting. Identity to figure out that this is the rightful person accessing this particular service, or payment from person to person or from person to retailer. Counting, as in things like DRM, to say, I have paid for 30 seconds of video or 2 hours of audio, allow me to access that service. There is no interoperable solutions for that. And we need them. And we need them to be open so that everybody can participate. It needs to come from the industry. And it needs to be interoperable between the different suppliers. And the Chinese operators are in a perfect environment to be able to look at these, because I know that they're doing a lot of pilots, and to be able to create these standards and influence these standards going forward. And this is one of my main interest areas in terms of interoperable electronic money that I work with on a day-to-day basis. Throughout the world, there's been a huge move towards greater financial inclusion. This is not just the developing countries or countries of the Asia Pacific. If you look at the United States and the information gathered from, say, the West Coast trials for mass transit, it's been shown that 60% of those people who use mass transit, want to use smart cards in mass transit, are unbanked, or at least very poorly banked. Now, China, along with many other countries, has a huge wealth which needs to be distributed amongst its population to carry on with the great economic growth that we've had. And we hear that China is about to beat Japan and become world number 2 in terms of GDP overall. This will lead to economic diversity and wealth distribution amongst all of those unbanked people will lead to a growth in the economy and bring stability to the nation. In order to do this, we need to bring the unbanked into society, into the economy. These unbanked are largely ones who operate in a cash economy. If you're going to bring them in, then you need an electronic equivalent of cash. Some people call it e-money, some people call it e-purse. Because cash only allows a face-to-face transaction. Once you can make that cash electronic, then somebody, the unbanked, can use that electronic money to buy their goods cheaper from further away, to sell their goods for more money further away, rather than be just restricted to face-to-face transactions. E-money applications are perfectly poised to be part of the phone. And the phone infrastructure means that the communication mechanisms are all available. The e-money application will mean that it's a multiple application because it must co-reside with the telephony application of GSM phones. So secure multi-applications within phones, within an NFC phone, means a secure multi-application platform. And again, Java card technology is the best secure multi-application platform we have. Despite the huge knowledge base in China and amongst Chinese operators, there's a huge amount of knowledge outside China. And there are many subcontractors out there operating in Europe and elsewhere that understand and know the international standards extremely well and can provide solutions that will be interoperable with systems that exist in the world. An example of this might be if a Chinese operator were to provide a money transfer service either to China or from China to elsewhere, then it requires a standard. No standard, no transfer. But I do believe that such subcontract work should lead to intellectual property sharing, where that knowledge comes within Chinese operators, so they're able to deploy that knowledge in further applications later on. Use of outside subcontractors, especially from Europe, would be a very quick way for Chinese operators to enter certain markets. Yes, there were problems with Java card quality in the early years. There's bound to be with any system that's built up over time. You could say that some of the specifications were slightly ambiguous. They could be read in multiple ways or executed or implemented in more than one manner. And indeed, there were a number of incomplete implementations and implementations that didn't quite work with one another, yet still passed the test suites. But these things got settled in time and is part of the learning curve that I talked about earlier. It did lead to some operators in the early years having their own test routines and only passing certain SIM cards from certain suppliers if they pass their own test routine. But this state of affairs has been moving forward very greatly, and in the last few years the experience gathered by all have been ploughed back to make the system much better. So what we have now is much greater interoperability of Java card technology between suppliers. And suppliers understand about open standards. They understand that they need to be highly compatible in order to have market growth. And Java card technology has shown that the market has been good for everybody. It's in everybody's interest to have compatible systems. At first, one can see that there won't be much change, short terms, at least within the internal market. Most of the subscriber base are reliant on just voice and data. But these subscribers will demand more and more applications with their newer technology phones. There'll be a need for secure multi-application environment before long. And this could be met with a proprietary in-country secure multi-application platform. It's not inconceivable that this will be developed within China. But then what happens? The organization that develops it will have a proprietary solution that will go to certain operators and not others. You'll get a segmented market. There won't be interoperability. And invariably, there'll be higher costs. And it'll take longer and longer to get an application to market. At an international level, it would be almost impossible to enter with a proprietary secure multi-application platform and fight the huge mountain that is Java card technology. It'll be difficult to integrate with other operators, and there'll be a need to adopt open international standards for the highest rate of return. Java card technology just provides that environment to move into without going through the pain of trying to create or replicate the same solution, but from an internal basis. It is just much easier to adopt something that has had years of experience in the market rather than create something new.